Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem. This is a palindrome pairs. So this is a hard type problem, and I would say a really interesting one. Okay, so we'll understand what this question is asking us to do and how we can easily solve this question. Okay, I'll explain it to you. Okay, so before moving on, if you haven't subscribed to Learn Overflow, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we are given a list of unique words. Okay, make sure the words given to us in our words array. Okay, that's all of them are unique. There's no repetition. So that's a list of unique words, and we need to return all the pairs of distinct indices ij. So we need to return a pair of distinct indices. That's the ing. This ing should be distinct, not same. Okay, in the given list, so that the concatenation of the two words like word I plus word J. So this should be the format, like word I plus word J. Okay, first word I, then words J. So if you concatenate them, this should be a palindrome. That's the question we have. So simply means let's say there's like if I look into example 2, there's bat, there's tab, fine, and there's cat. So you find a BAT and TAB. Look here, BAT is bat and then TAB. So if you write something like BAT and then followed by TAB, see, you will see a palindrome being formed, right? This is a palindrome being formed. And in the reverse way, if you find TAB first and then write BAT, that would be also a palindrome. So that's why the answer becomes like 0, 1, like index 0, then index 1, followed by index 1. And the reverse case, that is index 1 followed by index 0. So index 0 followed by index 1 and index 1 followed by index 0. So this is the case that's answer. But with respect to cat, like a third word given to us, we cannot find any length to it. Like we cannot find any palindrome to it or any part of palindrome to it. Okay, so we know that cat cannot be fitted into any of those. So that's not possible. Fine. Now that's the idea. This is the idea we went ahead with, and as I say, BAT TAB and then TAB BAT. These are the two palindromes possible. So this is the kind of expression they are asking us to find out. So we need to return the indexes of them. Indices of them, that is the 0, 1 and 1, 0. So the reverse is, if possible, we will add all that also. So there is a small case, there's a small by case in this. The case is the example 3. We should note into this. If we find a single letter, okay, if I find a word of length 1, fine, then we should also look for if there's any empty character there, like words having 0 length is also there or not. If such cases are also there, then we know that both of them is a palindrome. Okay, we should look for that. So that is a case we should keep in mind. Then if we look for the normalized case of everything, now see, you will not find everything in this format directly. You need to do some other operation. So let's look into that. So in example 1, you will find that case. What's that? It's like ABCD, and you find DCBA. So ABCD and DCBA, you find that that's a case something like this. Then 0, 1 and 1, 0. If you just reverse DCBA, that's ABCD. So they define 0, 1 and 1, 0. Fine. So that's the two cases that you can come across from them. But look here, look into this this 3 we have. In this 3, we have LLS and then S. For L, L and S, if we put the singular S in front, okay, we find that this is an palindrome. There's a palindrome being created, right? So that's why what we put like 3, like 0, 1, like 0, 1, 2, and then 3, fine, and then 4. So there's the 5 elements, that's 0, 1, 2, 3, 4 are there. So if I first put 3, then put 2. So that's why you see 3, 2 is the resultant in our output. And then we found 2, 4. 2, 4 means starting with LLS, and then we find SSSLL. So that's this one. Okay, so that's from the palindrome. We see that. Now the question is how we should look into this, how we should find the solution to this. Now, what you can continuously do is like take any two different like keep on taking two different values or two different words, just concat them and check if those are palindrome or not. But if you keep on doing that, that would be a huge thing. Why? Like if you just take two words like ABCD and DCBA, and you concatenate them, and then you just put in a function or each palindrome function, a different function, in that you just find out whether it's a palindrome or not. If you're doing that, then you need to remember there's a word length of 5,000. So for each word, okay, there's 4,900 times maximum can go a check. Fine, that check will go on. So that should be huge cases. And also, while you are finding a palindrome, you need to check for like maximum 300. So maximum 300, and the other word being 300 can be possible. So maximum 600 can be the like the cases length you need to traverse. What is the case I'm trying to say is like you took two words, okay? You took two words and then you concatenate them, okay? And then you put this whole new string into a new function is palindrome, and then check whether this concatenation is a palindrome or not. So if you can do that, but that's not the best way you can solve it. Like that's not the fastest way you can solve it. Now, once you got an idea that you need to do a fastest way, now what you can do is like use some kind of collections framework. What collections framework? If we use a hash map and store these strings, all the word string we have, okay, and store these strings in our hash map, what we'll do, what is the idea is like we'll map each of the string which are indices of that particular string. So what will happen, we'll take each of the string from that hash map or from the word list, and then we'll break it into parts. What I mean, let me just clear this thing. Say we got SSL. S uh, like three S's are there, and then LL. Right? That's the thing. Now, what we'll do, we'll find a substring of it. We'll keep doing a substrings of it. Like first the whole thing, then we'll to four of them, then we'll do three of them, and once we took three of them, okay, so idea is not in the Drake order, the idea is going in the reverse order. Reverse order is we'll go for LL, then S and S. Fine. So this is the idea. Now we'll take it the reverse, and we'll take that once we find an substring like LLS. So is that present in our like is that present in our particular word list? Like if it is, how we'll find out? We'll directly find out based on the hash map. Hash map will give us the string easily. Okay. So if this one is present in our particular word list, then it will be like whatever the current position of this, there is the ith position followed by like previously followed by the position we get from a hash map. Say by the get method, whatever we get. So this comma I, that gives our correct result. Like we just do a substring like SLL, and then we find that's also present. So this forms a substring for us. So we need to check a few things in the beginning. A few things is like without the substring, is the rest like what we need to check is like without the substring is LLS, right? Without the substring, is the rest is our palindrome? If the rest is our palindrome, that is in this case the 2s is our palindrome, right? So if see like our check for palindrome is so less. Why? Without this LLS, we just subtracted all the long form, like the huge elements, and then checked like only these two elements. Only these two elements are palindrome. Yes, they are palindrome. So we just checked whether this rest is present in our word list or not. If that is present, then we'll put the word list value in the front and then put the rest in our end. And the reverse is also true. We need to check in the reverse way as it is. Say we got LLS in the beginning, fine. So if we got LLS, only the other value in the beginning, fine. So in that we will check like if this S is present in our substring or not. Okay, if we find this is present, then we will check if LS is present. If I know LS is not present, then we'll find LLS is present or not. No, if find all the three are not present, like the equal copy is not present. So once we find this S is present, and we find that the rest of the string is palindrome, we're just checking for the rest. Okay, we're shifting a like part of it different, and we're just checking for the rest. That is the see when we are checking for the palindrome, the amount is getting so less. It's not checking for the all 300 word length. If there's a 300 word length, so you're not checking for the whole, but we're rather checking smaller values to get whether this is a palindrome or not. Fine. If this is a palindrome, then we find the rest of the part, this part, whether this part is present in our word list or not. If this is present in your word list, put that part in the beginning, and then it should end with or this value. So this is the whole idea of our question. Fine. So I hope this is understandable. So what I will do, I will quickly write a code for it. Just remember this formula, what we are doing. I will quickly write a code for this, and I'll again explain it to you based on the code how this idea that we are discussing over here, how this idea works in your code. Okay, you will see how fast this code can run. Okay, let's write this code first. And there you see this is like 276 ms. But if I just run it, if it will take much less, like it's around 250, 270 around that. So this is kind of the fastest solution you can get. So let's understand what exactly we did with the solution, or not with the speed. So first of all, what we took a hash map. This is storing a string and integer. So all those words. So we are doing something over here. I'll discuss it. And then we took a string set. The set is a tree set. Okay, that's why it's tree set. The tree set is by default. Tree set gives us a sorted order. Okay, from lower values to the higher values. By default, it's in ascending order, sorted. Whatever we are storing it is a sorted. But and we are storing an integer. Okay, and then we took n being word's length. What is a word? What is the string array that's given to us? Okay. Now, what exactly we did over here? We ran through all the words. Okay, we ran through all the words I0 to till n, and what we did, we put in a word map that is words of I, fine, and we just put I. So that's like we just map with the word with its index in our hash map. Fine, that's a name. We by name we give it a word map. Fine, and then what is the state we are doing? We just added that particular word length. Okay, whatever word is there, that length is being added with in our set. So what it helps us in it, it will help us over here. Over here, it will be helping us. So what it will do, whatever the length of this, say we are at this word. So this word got a length. Okay, and we'll check for words that are length less than this, right? Because we are doing the substring, as I said, we'll be doing the substring and breaking it into the values. So here it will be helping us check values less than this. And what will be the benefit of that? Benefit of that will be like, here there are 5 letters, right? 5 letters are there, 5 characters are there. But do we need to check all the characters? We need to check for S that of length 1. Then we need to check a character of length 3. Do you need to check for length 2? No, because length 2 is obviously there, not there in our words array, right? So there's a waste of time for checking that value. So say there's a 5 letter word, and the next letter word are of like all the letters are of length 300. So what's the point in, like, one letter is of 5, the other letter is of 300 length. Okay, I'm talking about each of the words. Okay, so in that case, if we keep on checking for all the values, that will take a huge time, right? That will be wastage of all the timing, like all the times we have. So in that case, what we'll do, we'll simply having a length, like all the lengths we so stored in a set, and that set is storing in a ordered manner, like in the lower values to greater values, fine. So what will happen in that way? We'll get so, like equal value, like we'll get only those values. Our set will be going through only those values. Our substring will be going through only those values whose length or whose type values are already there in our words array. Fine. So that's the point of taking a set over here. Next, we took our answer. This is a 2D list. 2D list, the final answer that we were supposed to return. Fine. So that's the point. We took a 2D list. That's the answer. Now, here we are starting an for loop. This for loop is giving us the exact answer, the whole for loop. So for loop, one for loop order of it. What we are doing in this, we are simply running from I equal to 0 till n. So n is the length of the word. So we are taking one of the words each one by one, and we're just going through that word. Fine. First thing, once we go us going through it, we just got the length of our current word. What's I dot length? Fine. And we're checking if our I length is 1. Okay. If in case our word's I length is 1, then what to do? Fine. If our I length is 1, then we simply are battling of this condition. So here you saw that the code gives some kind of wrong answers. I'll tell you what happened. So if our I length is 1, we're checking that if our word map contains an empty string or not. We got an length 1, okay, and we're checking for empty string. So empty string is of length 0. Remember that. So we got length 1 and we're checking for length 0. Okay, then we find that if it is there, word map has such value, then we get that the 2 indexes should be added. That is the current I position, like the current I, whatever the value, and the word map I value, like word map dot get this value, and the reverse one, word map dot get this value and the I position. So this is what we did, and then we just say continue, because we don't want to check this 2 values again and again, right? Because the other case, it will be like this will come up and then it will return as this a, right? So we don't want to do this. Like in the else case, if we don't find as empty string and the current length is 1, then we want to continue with it. We don't want to check, because previously I didn't write this continue and you were getting an error based on that, because the same thing was added 2 times, right? So that's the idea. That's the way we just built it. Now, what we need to do over here further, if the length is not 1. we are moving further. Now simply we just reversed our string. Whatever the current word we have, words I, we just converted into a string builder object, and then string builder dot reverse, and then converted that to a toString. That's being reversed to a string. So string builder is much faster in reversing our strings. Fine. So we're using string builder to just save time for that. Next comes an interesting part. Next part is we are considering if our word map contains this reverse. The way is ABCD is the current word, and we reversed it, and exactly we find that DCBA is also there. Fine. If a word map contains a reverse, then we are just and we're checking the word map dot get reverse is not I. That is the current value is not the same value. Like I mean, what the point is, they say there's exactly a value like A, B, and then C, right? Ignore that A, but anyways. So if they point at something like A, B, and A, fine. Let's take something like that. We got A, then we got B, and then we got A. So that's a word being in our array, words array, fine. So in that case, what's the reverse of this? Reverse of this is also A, B, A, right? So we are just ignoring that part. What we're doing, wordman dot get reverse not equals I. So that index is not I. If that index is equally I, then we are not getting a like palindrome pairs. That's a palindrome. That a word itself is a palindrome, right? So we are considering that this is not the I, and if that is not, then we are doing answer dot add I and the word bar dot get reverse, our current position and the reverse wherever we got. You may say why we're not adding the reverse as well as we are doing over here. There's no need over here because the next time we got this DCBA, we'll do a reverse again. Fine. The next word will be DCBA, and we'll do a reverse again, and then we will find ABCD, and then we'll add that to our list. Fine. So that is the idea. That is the whole idea because we are not doing a reverse over here. Fine. Next, what we're doing, we moved on. Now, this is the basic case of whether if the exact reverse is present. Now we need to break through this. We need to break through this in this format like how we're doing it. We are just moving through each of the sets, each of the set in the integers. So it's giving us like say currently there are LLS. Fine. Currently there are LLS is the third string. Okay. In the third string, we got what we'll do. We'll go for each in K in set. So K in set has a 1, then 3, then 4, and then 5. Right. So we just have a check if K is equals length being the current word length. What is the current word length? Current word length is 3. So we'll break that case. So first we will come across 1 in our set. So we come across S. Fine. Now we're checking if palindrome is a function that is checking for the palindrome. We took the reverse. What is the LLS reverse? SLL. That's the reverse of this SLL. And we were checking if the reverse of this is palindrome. Like first of all, what we're doing. First of all, we're doing length minus 1. Length minus 1 is like length is written in 3. So length minus 1 is 0, 1, 2. So that's what we got. Length minus 1 minus K. Minus K is K we got 1. 1 is the set value we got. So whatever we're doing exactly is we are simply say you have the reverse, that is S, L, and then L. Fine. So it's like 0, 1, and 2. Okay, understand carefully what we're doing. We are checking the palindrome of like 0. Okay, we're taking the left 0 and length minus 1 minus K. So it is 3 minus 1, that is the 2. So the whole thing, and then we are doing minus K. K is 1. Okay, we got this. And if the thing is, if we got this to be equal, like 0, 1, and 2. Now 3 minus 1 minus 2 is like 1. Fine. So we got 0 till 1. So if we just check our palindrome function, you will see it's like left less than right. So we got 0 till 1. So less than right is we are only checking for this 1, right? Only checking for this S over here in our palindrome. Okay, we're only checking for this S in our palindrome. That's what we are doing in the palindrome. If left less than right. So we are checking for this S. Is this a palindrome? Yes. So we are storing the rest, that is the string 1 in reverse or substring length minus K. So what is length minus K? Length is 3 minus K is 1. Fine. And we're storing in it what? We're storing 3 minus 1, that is 2. What is the substring 2? Substring 2 is only this part. Okay, so is it contains in our S1? No, this is not contained in our S1. Fine. So we cannot find as like L is not there in our word map. So this is not done. Fine. Now what do we need to do? We'll see the other way around. Other way around is See, other way around is the reverse way. The reverse way is we took our same thing S L L. So this is the word we have, and we are checking the palindrome in our K to L minus one. K is our one. Okay, 0, 1, and then 2. So we are checking for the palindrome from 1 till what is the L minus length minus one. Length minus one is 2. Fine. So we are checking for this values. Fine. Exactly, we're checking for this part. Okay, now what's happening in this part, if this is a palindrome, yes, 0L is a palindrome. Now what we're doing, we're checking like this S2 is creating and reverse the substring. Reverse the substring is like doing what? 0 till K is at this moment 1, right? K is at this moment 1. So 0 till K is what exactly we are getting? 0 till 1, that is this part is only we're getting. So that's the S2 the substring, we got this part. Okay, now we're checking if word map contains our S. Yes, this is true. This is true. Word map contains S. So what we did, we simply did word map dot get S2. What's so get S2? Get S2 is returning 3, right? This is the third position value we got. So word map dot get S2 is returning 3. And what is the current I we have? Current I we have is 2. Fine. So that's what we are getting. Word map dot get S2 is 3, comma I, that is 2. So what is the value? 3, comma 2 is the value that's getting. So first 3, then the I is 2. So that's what we are adding over here. See, this is the way the whole thing is working. Fine. And the next time, after K length increases to the next value, it will be like 3 is still because the length of the LLS 3, and it's fine. K length is 3, so we bracket to it. No point going through it, right? So this is the way we are just finding the solution. Okay, so I hope this is understandable of how we are finding a solution to this and how this particular method is working for us. Fine. I hope this is exactly understandable, and this is a pretty much faster solution, as I said, to 276. If I just try to submit again, it might reduce because that LeetCode just. So this is the particular way this see this went down to 149. 149 is like the 100% faster. You see the solution, you see what the type of solution it is. So this is 149 ms and like 100% faster solution we have over here. Fine. So this is the way we are solving this question. Okay, and that's how we are like storing the we are actually getting through this problem. I hope this is understandable, and if you have any doubts related to this, still you have any doubts, make sure to comment them down. I'll be happy to help you out in the comments as well. And like this video and share it with your friends who are doing today's LeetCode problem and facing problems understanding this question. I hope that will be helpful for them as well. Also subscribe to this channel for regular LeetCode videos like this. Hope to see you soon in my next video as well. Thank you all for watching this video. Thank you.